3 million years ago, a giant sloth nearly 2 meters tall slowly walked through a tropical rainforest. It had no idea that every step it took across a narrow strip of land was helping shape the history of our planet. The ground beneath its feet had only recently risen from the ocean floor. At its narrowest point, it was just 80 kilometers wide. Yet its impact on Earth, on the climate, on evolution, and even on our existence today has almost no equal in geological history. Its name is the Isthmus of Panama. And this is the story of how one seemingly insignificant strip of land managed to freeze half the planet, trigger mass extinctions, connect 2 continents, and today has become a stage for a proxy struggle between the United States and China. To understand just how extraordinary Panama's impact has been, we need to go back to a time when the Atlantic and Pacific Oceans were still connected. For tens of millions of years, warm equatorial currents flowed freely from the Pacific into the Atlantic through what is now known as the Central American Seaway. Water, salt, and heat circulated evenly. In many ways, the 2 oceans functioned as one massive body of water. Then tectonic plates began to reshape the planet. The Caribbean plate collided with South America. Underwater volcanoes built chains of islands. Over the course of 12 million years, those islands gradually moved closer together. The channels between them became narrower until, around 3 million years ago, the final gap finally closed. The Atlantic and Pacific Oceans were separated forever. What happened next created a domino effect that no one at the time could have imagined. Once the tropical waterway closed, the warm currents that had previously flowed westward were forced to turn north. This marked the birth of the Gulf Stream, the current we know today as the natural heater of Western Europe. But the consequences didn't stop there. The Atlantic, no longer receiving fresher Pacific water, became saltier. Saltier water is denser. Denser water sinks deeper. That sinking cold, salty water in the North Atlantic became the engine driving the global ocean circulation system we now call the Atlantic Meridional Overturning Circulation, or AMOC. This immense conveyor belt transports heat, nutrients, and oxygen throughout Earth's oceans. The important thing to understand is how fragile this climate engine really is. AMOC depends on one simple condition. The water in the North Atlantic must be dense enough, salty enough, and cold enough to sink. As that heavy water sinks, it pulls warmer water northward, keeping the entire circulation system moving. If those conditions disappear, the whole system can slow down or even stop. And today, signs of that process are beginning to appear once again. Greenland's ice sheet is melting, pouring massive amounts of freshwater into the North Atlantic. The problem is that freshwater is lighter than salty seawater. When freshwater spreads across the ocean surface, the water becomes less dense and has a harder time sinking. Yet that sinking process is exactly what keeps AMOC alive. As the sinking weakens, the circulation slows as well. A study published by the Potsdam Institute for Climate Impact Research in August 2025 issued a serious warning. Under a high-emission scenario, AMOC could completely collapse sometime after this century begins, with dangerous tipping points potentially arriving within just the next few decades rather than centuries from now. Climate scientist Stefan Rahmstorff described the situation as deeply alarming. The consequences go far beyond climate charts. If AMOC were to collapse, Western Europe could lose the natural flow of heat that has kept its climate relatively mild for thousands of years. Winters could become much colder, while summers could become drier. Rainfall patterns across the tropics could also shift dramatically, threatening agriculture in many countries that depend on predictable rainy seasons. Ironically, the ocean circulation system born from the formation of the Isthmus of Panama millions of years ago is now weakening because of human activity over just the past 2 centuries. What's even more fascinating is that its original formation followed what seems like the opposite path. As stronger warm currents carried more heat northward, the Arctic received more moisture through increased evaporation. That moisture traveled through the atmosphere and fell as snow over the polar regions. The problem was that snowfall increased faster than summer melting could remove it. Year after year, the snow accumulated. Its bright white surface reflected more sunlight back into space, cooling the planet even further. Ice sheets expanded. Around 2.7 million years ago, major glaciation began across the Northern Hemisphere. Massive ice sheets covered large parts of Canada, Scandinavia, and Siberia. The Ice Age had begun. And it all started because of a strip of land only about 80 kilometers wide. On land, The closure of the Central American Seaway opened the door to one of the greatest events in the history of life. Scientists call it the Great American Biotic Interchange. After the Isthmus of Panama formed, animals from North and South America began crossing into each other's continents. Giant ground sloths, glyptodonts, and giant terror birds traveled north from South America. From the opposite direction came horses, tapirs, bears, wolves, and saber-toothed cats. But the exchange was far from equal. Northern animals proved far more successful in South America than southern animals were in North America. Predators from the north, including wolves, saber-toothed cats, and short-faced bears, gradually replaced many of South America's native predators. Many native South American mammals eventually became extinct. The giant terror birds even reached Texas and Florida before disappearing themselves around 100,000 years ago. Of all the South American animals that migrated north, only a handful survive to the present day. The most successful are porcupines, Virginia possums, and armadillos. Then comes an even greater irony. The climate changes influenced by the formation of Panama also transformed Africa. Forests shrank. Savannas expanded. Many scientists believe these environmental changes became one of the factors that shaped the evolution of early human ancestors, eventually leading to Homo sapiens. So the Isthmus of Panama did far more than connect two continents. This narrow strip of land helped redirect animal evolution, reshape Earth's ecosystems, and may even have played an indirect role in the emergence of modern humans. For decades, the accepted answer was that the isthmus fully formed around 3 million years ago. Marine fossils, sediment records, and DNA evidence from organisms on both the Pacific and Caribbean sides indicate that the two oceans became completely separated around that time. A major 2016 study further reinforced a final closure approximately 2.8 million years ago. Then, in 2015, two separate studies complicated the story. Biological evidence suggested that plants and animals had already crossed between the continents multiple times much earlier, especially around 20 million and 6 million years ago. Another study discovered zircon crystals dating back roughly 15 to 13 million years within South American sediments that carried the unique chemical signature of Panamanian rocks. That suggests parts of the land bridge may have existed long before the final closure. A useful comparison is Indonesia. Bali and Lombok lie very close together. Kalimantan and Sulawesi are separated only by the Makassar Strait. Yet the Wallace Line shows that even short distances can divide completely different animal worlds because the sea itself acts as a natural barrier. Ancient Panama may have looked much the same. Rather than appearing as one continuous land bridge overnight, it was probably a chain of islands separated by narrowing channels over millions of years. That makes the story even more interesting. If Panama emerged gradually long before 3 million years ago, then its relationship with the Ice Age around 2.7 million years ago cannot be explained by a single simple cause. Panama was undoubtedly important, but it may not have acted alone. Sea level changes, long-term climate shifts, and gradual changes in ocean circulation may all have played crucial roles. That is why the geological history of Panama is still being rewritten. Today, the Isthmus of Panama's most visible legacy stands in the form of the 82-kilometer-long Panama Canal. This waterway carries roughly 5 to 6% of global maritime trade, serves more than 150 countries, and remains one of the world's most important arteries for goods, energy, and food. In January 2025, Donald Trump mentioned the Panama Canal during his inauguration speech. He claimed that China was effectively operating the canal and declared that the United States would take it back. The remarks immediately sparked international controversy. In reality, the canal has remained under Panamanian sovereignty since December 31, 1999. What concerns the United States is that two key ports at either end of the canal, Balboa and Cristobal, had long been operated by the Hong Kong-based company CK Hutchison. In early 2026, the conflict entered a new phase. Panama's Supreme Court canceled CK Hutchison's operating rights, ruling that the contract violated the country's constitution. As a result, the Hong Kong company could no longer manage the canal's two major ports as before. Panama then appointed Mars as the temporary operator. There were also reports that MSI became involved in managing the transition for other terminals. CK Hutchison rejected the ruling, initiated arbitration proceedings, and signaled its intention to pursue further legal action. From the outside, it appeared to be nothing more than a commercial port dispute. But because C.K. Hutchison is based in Hong Kong and the Panama Canal is critical to global trade, the dispute quickly became entangled in the broader strategic rivalry between the United States and China. A single decision involving two ports in Panama became part of a much larger contest between the world's two greatest powers. Millions of years ago, God closed a narrow sea passage here, separating two oceans. Today, humanity is fighting over who will control the artificial waterway that reconnects them. Amid all this geopolitical tension, another threat receives far less attention. The canal at the center of this global rivalry is now at risk of drying up, not because of war, but because of climate change. In 2023, an extreme drought forced canal authorities to reduce daily ship transits from 38 to just 22. Financial losses were estimated between $500 and $700 million in a single year. Many LNG tankers chose to sail around the Cape of Good Hope instead, taking routes roughly 30% longer because the canal could no longer be relied upon. Recent research from the University of Nottingham concludes that drought conditions once expected only once every few decades could become the new normal by the end of this century if greenhouse gas emissions are not significantly reduced. Millions of years ago, the Isthmus of Panama helped create the Ice Age by strengthening Earth's ocean circulation. That Ice Age shaped the climate that allowed human civilization to flourish. Human civilization then burned fossil fuels for 2 centuries. Now the climate change produced by that civilization threatens to dry out the very canal built upon the same land. 3 million years ago, 80 kilometers of land were enough to change Earth's history. Today, humanity is changing that same place through shipping, politics, and a climate growing increasingly difficult to control. Panama once shaped the world we live in. Now it is our turn to decide whether this tiny strip of land will remain a bridge connecting the world, or become a symbol that the planet has reached its limits.